I miss that countdown, that music that start the live stream. I dearly missed it.
I don't even like that countdown song, and I missed it also. As soon as it hit my ear, I was like, we're back, baby. This is great.
Exactly. Exactly. So first Cube First Live of the 2025 of the year. We are happy to be back. We're excited to be back. Some of us actually, but most of us on the team, we took some time off during the holiday. Should I say well-earned time off? 2024 was a busy year, if I can say.
You can.
And 2025 is going to be should I say a crazy one, but like a crazy good one. We have so much things on our plate and so many exciting things coming up. So we are back at work, refreshed and energized. Should I say that? I think it makes sense.
Yeah.
I think it makes sense.
And we're not the only ones coming back energized either. The team came back just with fire. I've been pulled into rooms in the wee hours of the morning with engineers just high-fiving over multi-cloud stories and authentication delegation stories and just all kinds of really cool finishing touches on a great platform. So excited for the new year, just like you, Fred. I think this one's going to come in with fire. And it's great to be back at Cube First Live, sharing cool cloud native tech with our audience.
It is. And I usually have a rule where I don't like say Happy New Year after the first full work week, but it's the first live stream. So folks, Happy New Year. I wish you all the best, everything you want from 2025. There is no other wishes that I can tell you. Just like hopefully you're gonna get everything you want, being happy, health, being a user of Cube First. It's probably something you want. So that's the year to make it happen. Welcome everyone. Welcome back to the live stream. As John said, we are just excited to be here again. And on that note, we start amazingly well. We have Frank with us from Yugabyte. Frank, how is life?
Hi, how are you? Really happy to be there. Thank you for having me here. Life is good. Starting the year with a lot of things, I'm developer advocate at Yugabyte, and we have a new release coming, I think, in two days. The year started quite fast. Yeah.
That's amazing. So you answered my second question I had for you, which was like, who are you? So you're a developer advocate at Yugabyte. It's nice to have like fellow developer advocates on the show. So thanks again for doing that. I know it's a little bit late for you for the show. So thanks again for joining us. It's really, really appreciated. So today we're going to talk about one of your main product, YugabyteDB. Am I right?
Yeah. So I'm developer advocate. So my job is just to talk about it and help users starting with it and doing demos and doing sample applications. So that's perfect, and really happy to talk about it. This means also that the more questions we have in the chat, the better it is. So people just do not hesitate to interrupt and in the chat, and that's perfect. Yeah.
Awesome. I agree with that. It makes the shows always more interesting when people ask questions for the guest about their technology or what they do. Or if you don't have any question, like sometimes just commenting on what one of us said, it's nice to have those comments. So do not hesitate if you're watching us live, or if you're watching the recording, you can have comments. It's just won't be live, but we will answer you. And it's going to be our pleasure to do so.
Indeed.
Yeah, so I think let's get started. I want to learn more about YugabyteDB and what exactly it is.
So I will explain the idea. So in the name you have DB, so it's a database, and it's a SQL database. And the big difference with many other databases is that it is distributed because today we want everything to be cloud native. We want to deploy on machines where everything can fail, and we just want the database to continue. And maybe I will just share a slide while I'm explaining. So basically, if we look at Postgres, so Postgres is a database. You have the application that connects to the Postgres instance, and you access data with that. You manipulate data, you modify data. And basically, if we look at the software, at the layers, when you connect to Postgres, you have a query layer that will read your SQL text, the SQL commands, parse it, analyze it, and build an execution plan with the access path to the data, and then read and write from the storage through the memory to the disks, and get data and give the results. So that's a monolithic application where you have a single instance, multiple processes, but a single instance. And what is the most monolithic there is that you cannot read and write directly to the disk. You need a place where all the different sessions will share exactly the same version of the database, and that's in memory. So you may read from the disk, but the buffer goes into a memory, and all processes access the same memory to be sure that it is consistent. The problem is that when you want to scale out, when you want to run on multiple nodes, multiple pods, there is something that is hard to scale. It's the memory. And this is why this is monolithic. So the idea of Yugabyte is to use the same query layer as Postgres, just because we don't want to reinvent one more database. And Postgres has so many features, SQL features, that first, we don't want to reinvent, but also we don't want users to learn a new database. And there is a big ecosystem of application. People in the chat can tell us if they use Postgres. Postgres is really popular today, either for new applications, but also for migration from Oracle or SQL Server for those who want to go open source. So basically, the idea is to reuse Postgres as much as possible. All this query layer part is stateless, means before accessing data, you can do the same thing on different nodes. And the application connects to one pod, for example, and that pod can process the SQL query. Another can do something similar on another one. Where it is not stateless anymore, where it has to communicate with the other node, is when you read and write data. So this part must be different than Postgres. And basically on each node, there is Postgres running, but at the level of the storage layer, the access to the table and indexes, this is where the software is different. It is distributed. So where Postgres reads and writes to the buffers in memory, shared buffers, and then to disk, YugabyteDB will send the read and write operations to the different nodes because data is distributed on different nodes. And not only send them, but also buffer them as much as possible, because you can imagine that you have a network call before accessing the memory, and then you want to pay the latency for each operation. So basically, that's the idea of the architecture. Run the query layer on all nodes and having a shared storage on it. And the shared storage, it's not the first database with this idea. This idea started with Google Spanner, which started to distribute the storage. Google Spanner doesn't have all the SQL features that Postgres have. So the idea of YugabyteDB was to take the same architecture to distribute data, but with Postgres on top of it. And YugabyteDB is open source, so that's also easier for people going to Postgres because it's open source. If they want to scale out, it's still open source. And maybe I can explain why scaling out, but I will show that in the demo. One reason we think immediately is just because you have a huge database and you just want to run on multiple nodes, because a single instance, even if a single instance can have a lot of CPU and a lot of memory, it's very expensive, and it's less expensive to run on multiple smaller instances. But the main reason to scale out, even for small databases, is high availability, because the monolithic architecture there means that if anything fails there, crash of the server, for example, then you have an application downtime. You can have replication to another one that can fail over quickly, but it's still a downtime.
Yeah.
If you run distributed on multiple nodes, when you distribute, you can also distribute to multiple places, multiple replicas, which means that if one node fails, the other can still access the data without downtime for the application. So resilient to failures. And also, even if it's not a failure, you may want to stop and start a node just to upgrade the OS or the software, the database itself. And again, you can do a rolling upgrade there if you scale horizontally. With Postgres, when you upgrade, you need to stop and start, and it takes some time. So
Yeah.
resilience.
I like that it's taking a software that is like well-known, like used a lot and like solid. Like Postgres is a solid database, and you make it so like it's distributed and it's more it's cloud native. I've seen like the issues I've seen with many people going like moving to Kubernetes is that they do mostly everything well, usually except databases. And that's kind of like the bottleneck of their whole architecture and like the failure, the point of failure of their application deploy on cloud on clusters.
Yeah, and even you can run Postgres on Kubernetes, and you can run it on multiple nodes, multiple pods, but only one will take the reads and write for the application. So you've in a marketing slide, it's nice. You can say, oh, we have cloud native Postgres because we run on multiple pods. But when you look at it, you have only one. And when you need to upgrade, you have to stop the application. So it's not so cloud native. It's maybe easier to deploy because you have all the operations that are automated in Kubernetes. So failover may be easier and faster, but it's still a downtime. Here, the big difference is that all pods are equal, are the same. The application can connect to any of them.
That's really fascinating. Yeah, in a prior life, I was a cloud engineer at a shop that, excuse me, ran a whole bunch of Postgres, huge databases that required all of these read replicas in all of their different availability zones. And it was architected in such a way, and this is a little bit dated information. This is going back maybe 10 years or so. But it was set up in a way where the replication needed to go to all the read replicas, but the only applications that were allowed to use those read replicas were the applications that were basically only read-only. And for any writes that need to go to the system, they all had to phone back home to the master, wherever the master was. And that added a whole bunch of configuration complexity to the way applications needed to be configured to the master. And then, but they wanted to prefer to use a read replica, but if the read replica wasn't available, it could fall back to the master and all kinds of complexities like that. From the sound of it, and correct me if I'm not exactly correct, but from the sound of it, this is just like a Postgres cluster. Like you get to interact with it like it's a single instance, and the mechanics of replication, the mechanics of the concern of whether or not you're connecting to that database for read purposes or write purposes, all of that goes away. This is just like you connect to this singular cluster instance and you can write to it. You can read from it, whether you're a read-only app or not. Is that an accurate assessment?
Yeah, exactly. For the application connects to any node and sees one database. one
Yeah.
logical database, even if it's running on multiple nodes. And all the magic is behind replication and failover, if there is something to failover, but it's transparent to the application. With a lot of code in the application, you can scale horizontally also. You can do some sharding, but then the application must know that, I don't know, for the customers with an even number, they have to connect to this database. And if they write, they have to connect there. And if they read, they have to connect there. And that becomes complex. Here, the idea is that all the complexity is within the software, which is also the philosophy of SQL databases. For example, in SQL databases, you have the ACID properties, the consistency. They are there to make it easy for the application. The application can run without thinking about race conditions, without thinking about what if someone else is modifying the same data while I'm doing. It's done transparently. Maybe the user will wait, but the user doesn't have to code for it and even test it because the database does it. And the idea here is the same for the failover, the same for the scalability. There are complex things done in the database, but for the user, you just connect like if you have a single database just for you on your on one server, and your codes, you can focus on the business logic because that's the goal of the developers. Do not code for the infrastructure, but code for the business logic. Yeah.
So wait, you're telling me that like if I have an application that won't run with PostgreSQL, or I can just like move to Yugabyte and it's basically working.
So the goal is to be fully compatible. There are only two things. First, it's mostly optimized for OLTP. The goal is not, you can run a data warehouse on it, but it's not optimized for it because the priority is for OLTP. This is where we need this kind of database with full consistency ACID properties. So that's one thing. And there are also some features that are not yet supported, but then it goes really fast because it is reusing Postgres, and then there are a lot of features. They just have to be tested. A few things may be done differently because of the distributed storage. For example, the query planner must take into account the latency in it, but most of the features are there. And for example, today, YugabyteDB is compatible with Postgres 11 features, which is quite old. But in 2 days, we have the new release that is compatible with Postgres 15. And that can go fast. Just merging from Postgres the new features to get them. It takes a bit of time to merge them, test them, and make sure that everything is optimized. But also the big advantage is that this will be rolling upgrade. So application can go from Postgres 11 to Postgres 15 without even stopping the application. And when you look at the detail about the Postgres catalog, you can see that it's not something easy to do. And that's why it was long between Postgres 11 and 15. It was not only merging the new features, but also building the framework that allows, basically during the rolling upgrades, it runs with 2 catalogs in the 2 versions and do some kind of internal replication between them.
That sounds amazing. So yeah, someone someone was saying like, oh yeah, Postgres 15 in 2 days. So that's a good thing.
It should be in 2 days. I think we didn't put the date publicly, but I already have. Actually, people can run with it because it's open source, and if you build from the master, it was already merged into the master a few months ago. But we release the containers and the binaries very soon.
If it's not released in 2 days, Frank, I'm gonna call you personally and ask what's happening.
Yeah.
That's a joke.
No, but I did, when I started at Yugabyte, I mean, a few months later, that's an interesting story because people were asking about the Postgres compatibility, and we had this project to do it, but it was never prioritized. So I was telling people, yeah, it's soon, but soon finally took 2 years, mostly because it was not prioritized, because people ask for the latest version. But when you ask them, but which feature do
Yeah.
you need from this version? Nothing was blocking. So they had workarounds. So finally, when all your big users just tell you, yeah, we want it, but we don't have a good reason, then it's like, yeah, we will do it, but we don't have a good reason to do it immediately. What
Right.
has changed is that Postgres 11 went end of support from the Postgres community. And then a lot of tools in the ecosystem started to, for example, Hibernate started to put a warning in the logs telling,
Yeah.
be careful, you are on something unsupported.
Yeah.
And there people care. Also, auditors for security. Because it's Postgres compatible, they run the same scripts to detect the security level of it. And they detect version 11 and they say, oh, it's end of to support, it's bad for security. It is not, because even if we are compatible with 11, we still fix the security issues if they are there. But yeah, it's more for those reasons. When the tools detect that it's an old version, then the priority is there. So
Yeah, and the end of life support like does not always mean there is security issue. Like obviously, if after like they stop supporting it, there is like security problem, like that may become an issue. But it's not because like, oh, today's the end of life of a product or end of support that like voila, now you have like a bunch of security issues happening right
yeah,
now.
but
Yeah,
it's so easy if you are a security auditor.
yeah.
It's so easy just to look at the version and parse the number and then say, oh, warning, without looking at the details. So yeah.
That's true. John was having another guest on the show, Bigfoot. How do
Stinky
you call him?
Bigfoot trying to make an appearance. It's terrible.
Stinky
It's
Bigfoot.
terrible.
Well,
John's cat. Frank, we have a question before you move forward. I don't know if you're going to talk about it later. If it's the case, just let us know. But Piet was asking for rolling upgrade. Like, is it possible to do rolling upgrade so a cluster can run for a quote unquote small period with software that is Postgre 11 on some nodes and Postgre 15 on others?
so yes, to be rolling upgrade, we need to run with nodes with different versions. But the only thing that you cannot do is DDL. Changing the schema, adding or dropping columns in the tables. We just disabled that for the time of rolling upgrades, just because it's easier. We run with the two catalogs, so it's easier to have a one-way replication rather than a two-way. And usually when you do a rolling upgrade, it takes, I don't know, half an hour, 1 hour. I think it's possible not to do an application release exactly at the same time. So that's probably okay like that. So it's a small period. The goal is not to run for long like that. Also because all the new features that come with it are enabled only when all nodes are up to the latest version. Because you don't want a Postgres 15 writing something that will be read by Postgres 11. Don't take that risk. So the idea is that it's fast, to leave you time to do the rolling upgrade. And if anything fails, maybe you didn't test well the application and something is not running on a new version, you can also roll back to the previous one. So the idea is just to have no stress with downtime and maintenance windows. You can do it. It takes half an hour, it takes 2 hours, still okay. But of course, you don't do it when you have the peak of activity. Don't wait Black Friday to do a
Yeah.
rolling upgrade plus an application release. That
Yeah, not a good idea. And I would assume also that someone would test this in like a development environment, like or staging before moving to prod. So
yeah.
once they move to prod, the rolling upgrade should be easier. So Piet was saying like understanding no DDL during upgrade. And other questions, new features only come available well when all nodes are upgrades, from what you said.
Yeah, so that was also part of building a framework to allow those upgrades. Postgres can change the behavior from one version to another, or can change catalog views. And then something can be broken. So the idea is that you do rolling upgrades, you have something that is compatible, and then you enable the features when you know that all nodes are done, but also when you have validated your application, you know you don't want to roll back. And then you can start to use new features without risking to have something to do to roll back.
That sounds good to me.
Okay. Yeah, I've put a slide just to describe how I will deploy. I have deployed it for the demo on Kubernetes. So I said that you have all pods that are equal. So you have Yugabyte running on all pods there with local storage, because that's the goal. The database shares the data, which means that you don't need a shared storage. You access local storage on each of the nodes. And but we will see in the demo, I will explain. There is also another stateful set that you don't have to scale out more than the replication factor for resilience. That is called YB master. I really don't like this name because it looks like you have a master and a slave or whatever. The YB master is more a maestro, is the orchestration, the control plane. For example, the cluster metadata. For example, just the list of the pods. When you scale out, you scale out you scale the stateful set. It adds a new pod. How does it join the cluster? Just it contacts the master so that the master can tell all pods there is a new one there. And basically, the application connects to the YBT server, so the pods who really process your SQL query and run the reads and write on the storage. And the masters are more for the administrative commands. But then the best is to show it.
Yeah, and just before that, one last question from Pierre about the upgrade. I missed it before, sorry. But the upgrade is in place. Like once the upgrade is in place, for example, higher version nodes will read the same data. Not that upgraded nodes can only join as new nodes.
So yes, it is in place. You can also add new nodes with the new version and let the data be rebalanced and then remove the others. But that involves some data movement. So if the database is large, you probably don't want that. But it's still a possibility. But it can be in place. So you for example, on Kubernetes, it's quite easy. It will just restart the pod attached to the same persistent volume and restart the pod with the new image.
Sounds good. And Frank, the demo you're going to show us today, it's also, you wrote an article about that on the FTO. So I'm sharing the links for folks. It's distributing PostgreSQL on Amazon Elastic Kubernetes. So you have the link there if you want to try it at home after the live stream. Listen to Frank's demo, but after the live stream, if you want to try it at home, here's the link for you. So Frank,
yeah, and most of the commands I will run are in the blog post, except if we test something else, because it's always good to test something else when it's live. So here I have an EKS. Probably I have it somewhere just to show. I deployed EKS, so the managed Kubernetes on AWS. I have 4 nodes there. And just to show what I have already deployed, because it takes a bit of time, but we can go later into the deployment itself if you want. So I have stateful sets. So first, I deployed in 3 stateful sets for the 3 regions. That gives better control about what runs where. because when you have a database, you want to know where the data is. And also, when you start the tablet server, they must know where they are, because, for example, here, so the YugabyteDB server that holds data, I have 2 replicas in each zone. In 1A, I have 2. In 1B, I have 2. In 1C, I have 2. And I start YugabyteDB with a replication factor 3, so that there are 3 replicas for each data. It's all distributed, so one row can go there, another row can go there. It's sharded and distributed on the primary key. But as the database knows where the server is, it will take care that the replicas are on different zones. Because of course you do that for resilience, and then you don't want 3 replicas in one zone and then have to stop the database when the zone is down. So this is why we need stateful sets, where the difference is just that this one knows it is in 1A, this one knows it is in 1B, this one knows it is in 1C, and then data will be replicated on all of them. So I have just 2 replicas per zone, and the T server is the thing that we can scale. And I have 1 YB master on it, which is the control plane for it. Doesn't need to have more because it's really just metadata. It's really small. There are 3 just so that it continues to run if one is down. And so we can see the pods there. So basically, the pods that we have seen already in the stateful sets. And we have services. Just showing the services. So let's take in one zone, the most important for the application is the one where the application will connect with the Postgres endpoint. And that's the YugabyteDB server, but behind a load balancer that is YugabyteDB server service. So I have 1 load balancer in each region, because the idea of a deployment in multiple zones or multiple regions, it's zones. The idea is that you have the application server also running in each zone, and it connects locally, because you don't want to connect from one zone to another one and maybe read data that comes back to it. And also for high availability, if one zone is down, the pods of the database and the pods of the application will be down together. So you have lost those connections, of course, because they are not there, but the other ones are just continuing. So this is why there is a load balancer for each. Of course, you can have a load balancer that goes to all of them, but it's probably better for high availability to have a load balancer in each of them. And there is also a kind of UI. This is a very basic UI just to check what is working, and I can show it. So the UI is provided with a small HTTP server in the YB master, but it will help to explain the concept. So the cluster is called the universe here. I am in replication factor 3 copies of the data. Why 3? Because if you have only 2, and if you have 2 and 1 is down, then you can run on the other. But if you have 2 and the network is down between the 2, you don't know which one was as the truth. If you have 3 and you cannot access to 1, then the 2 others knows that they have the majority, and then they have the latest data. I will explain a bit more about that. So basically 6 nodes, replication factor 3, and that's the version. And the YB master as well as the T servers are using Raft, the Raft consensus, to distribute and replicate data. And with Raft, you have one in a Raft group, you have one peer that is the leader and the other that are followers. the idea is that all the reads and writes go to the leader because you need a single place to be sure that you are consistent. If you read from a different one than where you write, you may miss some of them. So you have a leader, everything goes to the leader, but is replicated to the followers, and the leader waits for the majority of them. So one can be down, it continues. But if the leader is down, you know that you have the latest data in one of the followers. So each follower doesn't know if it has the latest data because maybe the other has acknowledged. But if they talk together, they can quickly see which one has the latest and elect a new leader. But I will show what happens when there is a failure. That's exactly the thing. It can elect a leader quickly. So looking at that, it looks like we have one leader and followers like a primary and standby. But the point is that before that, data is distributed. So one row has a leader in one pod, but another row may have a leader in another one. We will see that in the tables, but for the moment, I didn't create any tables. So the best is to start to connect and do something on it. So just showing the details because the line was too wide, but here I show one service. I probably copy pasted something wrong.
Here you have two common in one.
Oh yeah, I don't know why. Since yesterday, my mouse is pasting 2 times. No? Sorry. Let's take it. Okay, I will do it differently. Just copy pasting like that will be better. Okay, I just wanted to show that this service, so it's a load balancer. It has an external IP. I opened everything, so if someone wants to connect, please do not drop the table. And you can see the endpoints. The Postgres port, the default Postgres port is 5433, and for Yugabyte, the default we use 5433. Sorry, the Postgres default is 5432, and we use 5433. So I can connect to this port on any load balancer, on the load balancer for zone A, B, or C. So let's do that. So I will do my copy paste differently. Let me just start a Postgres image just to use the Postgres client to show that it is compatible. I will use PSQL, the Postgres client. And I just have to export the host name that goes to the service and the port, and the host is just YugabyteDB servers from the service there. And I will initialize some data. I'm using pgbench, which is a tool that comes with Postgres just to create some example tables and run some kind of benchmark on it. And I'm running that just to show that something that is made only for Postgres just works the same on Yugabyte here. So it has created some tables, some primary keys, some foreign keys, all SQL features. For the moment, the tables are empty, but I can already show if I go to this UI, if I refresh that, I can see there that I have some tables. So one of the tables is PG accounts, and I will show the detail. I will start to load data and show the details a bit more later, but just to show that for one table, I have multiple tablets. Here I have 6 tablets because by default, it creates one for each pod to distribute. And I can see that I have a partition key that is a hash value. By default, it will take a hash, apply a hash function on the primary key. And this is how it will decide to distribute. So if I insert row with primary key 10, the hash value is calculated, and this hash value may go to that specific tablet. And if I insert with key equal 12, that may go to another tablet. This is how it is distributed. And each tablet is a raft group with leader and follower. And it is, as I said, the reads and write go always to the leader, but the reads and write for one row will go to the leader that is here in T-server 0 zone 1A. But for another row, it will have its leader on another one. Here is 1B, for example. All are replicated as followers on the different zones, 1C, 1A, 1B, but this one has the leader in 1B, where this one has the leader in 1A. So finally, except if the application is always updating this one single row, which is not the goal of a database, if you have a real workload, then everything will, every nodes will be busy at the same time. And I will import some data still using pgbench. So that's the pgbench command. I passed some options just to do bulk loads to go faster. So just inserting some rows in those tables. And if I look at what happens there, so that was table. I can have the details of tablet servers. So I have 6 tablet servers, 2 pods on each zone. So T-server 1 and T-server 0 in zone 1B, 1C, 1A, that's 6. They are alive, all alive, that's good. They have some tablets because we have seen I have 4 tables and 6 tablets for each. So 4 times 6, I have 24 tablets, and they are distributed and replicated. And we have somewhere the read and write operations. So you can see that here I have 45 operations per second. It's just a batch of inserts. But the important point is that even if I'm connected only to one endpoint, because I didn't start in parallel the initialization of the data, all pods are busy doing the same amount of work, the same amount of writes, because it is distributed. If I refresh, okay, so it's already stopped, so we have 0 there. Basically, rows were inserted. And this is done, pgbench with the initialization is not multi-threaded, so it connects to only one endpoint. There is only one endpoint getting the SQL command for it, but then the reads and writes are distributed to multiple nodes.
Frank, let me ask you, how far can the replication go? Like it doesn't take much imagination with this demo to understand it in your Kubernetes cluster, in your production cluster. But you know, maybe you have production East and West, maybe you have production AWS and production GCP.
Yep.
Can you join Yugabyte clusters across clouds, across
clouds, across region? The only thing is that you have to take care about the latency. So basically, when you read from the leader. So the idea is that if you distribute in multiple zones, there is 1 millisecond between the zone. So probably it's the same. The latency between 2 nodes in the same zone in AWS or 2 zones is nearly the same. So in single region, you don't really care. When you deploy in multiple region, let's say 2 regions in Europe that are 10 milliseconds and 1 region in US West, and then you have 100 milliseconds. So first, you don't want to have all your reads from Europe going to US.
Yeah.
So usually when you do that because you have a global applications and you have users in all countries. But probably you want for example, let's say you are a bank, you want the bank account for your customers in Europe to be in Europe. For 2 reasons: latency, because most of the time they are in Europe, so latency will be smaller there. but also legally, you have to store it there.
Yep.
So for this, you still deploy the same, but you add some placement information. In a table, you may partition it on the country. And so same partitioning as in Postgres, and you assign table spaces to each partition, similar table spaces as in Postgres, except that in Postgres, the table spaces are there to put in different file systems. In YugabyteDB, the table spaces will be used to put a different placement info, and the placement info will be cloud, region, or zone. So for example, you can say that you have you partition your table on the country, and country France, Switzerland, Germany go to Frankfurt AWS, and country US, Canada go to maybe another cloud in US, and this is how you decide it. And then the database will automatically go into one partition depending on the country that is in a column of your table. So that's just Postgres doing partition pruning.
Yep.
And then Yugabyte will take care that the placement info for the partition will be there. For example, if I go to a table there, this one, for each table, there is a replication info. And here the replication info is this table has 3 replicas. So each tablet, the little shards in this table have 3 replicas, 1 leader, 2 followers, and they are distributed in 3 placement blocks. This placement block is AWS U West 1C, the other is 1B, the other is 1A, and I need at minimum 1 replica on each. So this is how it distributes on different ones. If you use this partitioning and table spaces, then you may have something additional like placement in a specific region for all of them, but also leader preference. So for example, here the leaders are distributed, but the leader for my customer in Europe, I prefer it to be in Europe. Even if I'm allowed to store the data in, or let's say the users in France, I put the leader in France, and maybe the followers can be in Germany, but better have the leader in France. If France region is down, then the leader will be elected in Germany. That's okay. The latency will be a bit higher, but when everything goes well, then the leader is placed. So with placement info, this is, you cannot change the latency between the region, that's the speed of light. But what you can change is the placement of data when you know where the user are connecting from, place the data closer to it.
It's really neat.
So yeah, that's we have big customers using multi-cloud. There are 2 main reasons to use multi-cloud. First, even if you run in one cloud, it's always easier to know that you can change, and then be multi-cloud for the time of the rolling migration of data. So you run everything on AWS, you start new nodes on GCP, and data rebalances, and then you blacklist the nodes in AWS, and then it continues to rebalance everything, and then you can remove the other one. So you run on multiple clouds just for the time it takes to move the data, and that's the most common. There are also some running in multiple clouds. Of course, it has a cost because the connection between the clouds you have to pay to both sides. But for example, there is a big retail in US running on Yugabyte, and because they are retail, they don't want to run on AWS because it's Amazon, it's a competitor of them. But they also want to be sure that they will have enough instances for Black Friday. Yeah. And they're not sure that one cloud provider will have all the instances they need. So they run on 2 clouds, and then they know that they can scale with that. Of
Fascinating.
course, it has a cost. Yeah.
I like that. John, I know where the question was coming from. Our amazing team of engineers just to implement it. It's not released yet, but they just implemented multi-cloud within KubeFirst. So really soon, within your management cluster, you're going to be able to create workload cluster in different clouds, which going to be helpful for many enterprise users we have. So.
Yeah,
That's really cool, because setting the network between that. I mean, here I deployed on EKS where the network is there, but already multi-region, you need to do something. And multi-cloud, I think having a Kubernetes on multi-cloud, you have to think about the network, and yeah, if it's automated, that's easier. Yeah.
Yeah, 100%. Yeah, it's hard to not have multi-cloud on my mind. He starts talking about geographical distribution, and I'm just like, oh boy, this is fun. And the data on the replicas. Am I understanding it right that it's a full copy of the data that's being replicated, or is it sharding the data?
So it's a full copy in total per zone. For example, here I have 3 zones and 2 nodes in each zone. So I have a full copy of data on each zone, because that's the goal for resilience.
Yep.
But not a full copy on each node, just half of it on each node. So that's one thing. And the copy is per tablet. So it's not like you have one big database that has one big replica, and if there is a new replica to set up, then the whole database must be transferred before it can be used.
Okay.
Here, the idea of tablets is that it starts with a few of them, depending on the number of nodes. But when you load more data, tablets will be split. For example, we see a split depth here. It's 0 because I have no data, not a lot of data there. They are split. So the goal is that YugabyteDB will take care that the tablets are always maximum 10 gigabyte, 100 gigabyte. That's okay, but still an amount that is okay to move if there is a reason to move, and easier to manage. Yeah. Let's run, for the moment I have data, let's run something on also, or maybe first I will show with PSQL. So that's the basic client command line Postgres client, and everything works. I mean, I can list my tables. I see that exactly like in Postgres. I can look at it. There are just a little, some little difference. By default, it applies a hash function on the primary key to distribute it. And so this is visible here. It's just something added to Postgres. Postgres has indexes with ascending or descending, and we can use that. Then it does range sharding. But if we want better distribution on something where we know we don't have range queries, then we can choose hash for it. Can look at the size of the tables there, and let's run something. So here, so pgbench is just running a workload on them from multiple clients. So this starts 20 client threads, and it connects to the connections go to the load balancer in one zone, because this is what I've set for the destination. So like an application server that can connect to any pod in the same zone. So basically my 20 clients are distributed to 2 tablet servers. I have 2 tablet servers that can parse and execute the SQL, but then the read and write will go to multiple nodes. So now if I look at the activity of the tablet servers. So before, when I was inserting, I had only writes, but now I have reads and writes going and fairly distributed between all nodes. Reads and writes there. So the case where everything runs, no failure, you have all nodes working there, in all zones, taking some reads, some writes. One is taking reads for a part of the data on the hash value on the primary key. Another one is there. So globally, everything is distributed.
Very nice, Fred.
No, I need to celebrate the win. While we wait for the testing to complete, we have another question from Pierre. Thanks for asking those questions. As we said, I think it's always nice to have something that where people participate. So Pierre was asking, when heading nodes, does it always mean a redistribution of data? Can I have nodes as CPU plus mem only, but without redistributing data onto them? Supposedly I can remove those nodes easily because there's no data.
That's a very good question. First, I will scale the pods to show what happens when we add new nodes that add CPU, memory, and storage, and then I will talk about it. So what I will do while the application is running there, I will scale my stateful sets. So I add in each region, I add a stateful set with 2 replicas, 2 pods. And if I scale, so Kubernetes, I scale, I have a namespace for each zone. I scale the T-server stateful set to 4 replicas. And I will do the same for 1B and 1C there. So here it will create 2 more pods in each zone. And you can see that the application just continues. The throughput is a bit higher because there are more nodes. And the application just continues. And if I look at the activity on the pods, so I didn't refresh yet. So this was still with 6 pods in total. If I refresh, automatically it has detected that there are more pods. And some of them are already taking some reads. And if I refresh at some point, they will also take some writes. What happens if I go to a table to see, maybe I'm fast enough to show what happens. What it does, so I add new nodes. They have nothing on them. So already, those new nodes, new connections can connect to it, but it has no data. So reads and writes will not go to them. Yep. But the database has detected that the cluster is not well balanced with that and will start to rebalance. So basically, creating one more follower in one of those new nodes. So I'm quickly checking if I was fast enough to see one with 4 followers. I think this, yeah, for example, this one. The normal way in replication factor 3 is 1 leader and 2 followers. And here we have an additional follower. So my new nodes were probably T-server 2 or 3. So probably this one. So it has created a new follower and it has even elected it as a leader. And quickly now, if I refresh, probably one of the old followers has been removed so that it is rebalanced. So there are 2 steps in rebalancing. First, adding new followers, and then electing some leaders because leaders do more work. They receive the reads and writes. So this is rebalanced. So that's the basic rebalancing where it rebalances everything. If you want to add more query layer without storage, you can blacklist a node and it will not have data on it. The feature is made more when you want to scale down. If you want to scale down, if you stop many nodes, half of the node at the same time, then the database will stop because it is resilient to one zone down, not more than one because of the replicas. But what you can do is start to blacklist the nodes that you want to take out. and then data will move out of it. So if you start a new node already blacklisted, it can take new connections, but has no data there. That's a way to do it. So here, the application is still running. So basically, typically, I have a database. I don't want to run with the biggest instances because then my bill to the cloud provider will be too high. So I run with the minimum I need, and suddenly I see that I have more activity, or I anticipate that. For example, tomorrow I know that the marketing is sending emails with big promotions, and then probably I will have more users, and then I start new nodes. And as soon as the new nodes start, the throughput starts to increase. And when everything is rebalanced, it can double the throughput. Here it didn't double because I have really small nodes. So I think I have a bottleneck elsewhere because it's a lab. But basically, the idea is that it scales linearly. If you double the number of nodes, you can double the throughput, except if you have a bottleneck with everyone updating the same row, for example. And this is completely online because if you have a monolithic Postgres, if you want to start a larger instance, at some point you need to stop it and start it. You need a downtime even to scale up. So here you can just scale out. And if you want to scale up, you can also start a larger instance and then remove the other if you don't want to multiply the number of nodes. So yeah, you have this choice. So that's the first thing. Elasticity. You want to increase the power without stopping the application, and that's a possibility.
Very neat.
And then while the application is still running, we will test something else. So the resilience. Let's say that, so let me copy paste. I will stop one pod here. So I have 4 pods in all regions. I will, let me copy paste that. So in 1C, I'm scaling down to 3 replicas instead of 4. So 1 is just killed by Kubernetes. I see that I have only 1 error, and that can happen if I'm really not lucky.
Right.
I will explain
Contact
that
at the moment.
just later. Just before, just look at what happened there in the throughput. So I'm showing the throughput every 5 seconds. So you had the throughput about 700. I will talk about this error there from one client 15. Then for 5 seconds, 5 more seconds, the throughput was really low. And then it's going to normal there. So from an application point of view, what happened there is that for a few seconds, it's slow. Those few seconds are not the election of the new leader because this can be done immediately. But we don't want to elect a new leader just because there is a network latency a bit higher. So by default, in the configuration, we elect a new leader when it does not receive the heartbeat for 3 seconds. So that explains why for 3 seconds at least, we don't try to start a new leader just to wait to be sure that it's a network error. And then there can be also a TCP/IP timeout that can be set also. But the idea is that in most of the case, there is no error. Here we had one because one of the transactions were in doubt and it detected a duplicate request. During the replication, it can retry a transaction. A transaction that failed will be automatically retried when the new leader is available. So that's the failure is transparent to the application. But if you are really not lucky in this retry, maybe the transaction were already replicated on the leader. It retries it, but it detects that it's duplicated. You don't want to run it 2 times, and then you have an error. But that's only one client in a connection pool of 100 of them. And also I'm using pgbench here, which can connect with multiple sessions, but doesn't have a connection pool, with a real application, the connection pool gets an error and will restart it, reconnect it. So that's typically the maximum outage that you see when one node is down. A few seconds of performance lower and maybe 1 or 2 errors, and then it just continues. And this can be just a crash of a server, but you have the same if it's the whole data center that is burning. For example, if I scale the same but to 0 replicas, then I have a full zone 1C that is just not available. And I have again one duplicate request there, and maybe some TCP/IP timeout for a few 5 or 10 seconds, and then it just continues the same there. And if I look at what we have first in terms of tablets, so if I refresh, what happened there was just that the leaders who were on the nodes that are down are not leader anymore because they have a lease. So they are leader only for 2 seconds. That is renewed, but if they have no news from the others, they just don't have the lease. So here they are down, so they just don't continue as a leader. And then another one is elected. When the followers get no heartbeats from the leader for 3 seconds, they know that something is wrong with this leader. They talk together, and because they have the majority, they know that they can continue. You don't want a split brain where you have 2 leaders. So you will never have 2 leaders with this, and this is based on Raft and leader lease there. If you look at the tablet servers, I think we still see, so those are the pods in 1C that have taken down. So it knows that they are dead, not responding. This is the heartbeat. So not responding for a while. So no reads and writes to there, but they are still there considered as a follower. So for example, let's take, so that's 1C. If I go to one table and I search for 1C, for example, this tablet has the leader in 1B. 1B is up. It can take reads and writes. The writes are sent to the followers and need the acknowledge of one of them. So obviously this one acknowledged. This one is down, so cannot acknowledge. So the idea is that usually those failures are short. So it continues to run just with one other acknowledging. That's okay. You cannot afford one more failure because then you will have another follower that will not answer. But the idea is that for a short time, it doesn't try to start a new replica elsewhere because in the majority of cases, it will come back when the network is okay. And by keeping the follower there, when it comes back, it will just have to catch up with the latest changes and be a follower again. By default, but that's configuration, you can choose it. By default, we stay like this for 15 minutes. After 15 minutes, it's considered as gone, and then it removes that follower. It will bootstrap a new follower on your new node that is there, but this one will have to get all the data for the tablets. So really the idea is that you have short failures and you just want to continue until it's back, and you have failures where it's a bit longer than short, and then you really want to automate that. But the big thing is that in this, it's all the database doing that. The only commands that have run were Kubernetes commands.
Right.
I didn't tell the database that there is a new node. I didn't tell the database that be careful, a node is down. This is automatically detected. And this is what is really cloud native. The database is cloud native because you have only cloud commands, Kubernetes here, to manage the infrastructure, and that the database detects the things automatically. Of course, if I want to scale down, either I stop a node and then I wait 15 minutes so that it is really considered done, and I stop another. But if I want to stop many nodes, for example, from a zone, this is where I blacklist to tell the database, stop replicating to those one because I have the intention to remove them. Okay, so here basically the application is just running without downtime. I will not show that here, but if you want to do rolling upgrade, it's just changing for the stateful sets, and I think everything is set in the stateful sets to do rolling upgrade. So not stopping all the pods at the same time when you change something like the image, and that just works here.
Frank, I'm dying to know more about your open source and your pricing model, and just anything that you can share with me,
Yep.
Selfishly, and our audience. What are we looking at here? Is this the open source implementation that we're looking at?
So all the database is open source. So basically, all the database is on GitHub, open source, and all features are there. It's not like if you do backups, then you need Enterprise Edition. All the database is on GitHub, so it's YugabyteDB GitHub. The only thing is that it's an ugly name because it's YugabyteDB without a dash, but historical reason it had a dash, and when you search for it, that probably it's not the best idea. But basically, it's all there, and there is only, I was looking for the license. It's all Apache 2, so you can do whatever you want with it. You can even build your managed service if you want. But the idea is that Yugabyte is probably the company that knows better how to manage it. So the commercial offer is only service, so support and managed service. For example, on cloud.yugabyte.com, you have a cloud. Let me just connect to another one, just an internal one where I can create whatever I want to show you how it looks for the database service. And so this is just automation. For example, I have already one that I think is paused, and we will have a critical maintenance, so probably a rolling upgrade happening one day. So basically from there, you provision a cluster. So that's a managed service. So the database itself, the software is free and open source. But if you want it managed and running on one of the free clouds, so AWS, Azure, or GCP. If I take AWS, so you can choose the versions and connection pooling. I was just for probably the next screen, and you can choose the deployment. So can be single region, similar to what I did, 3 regions in an AWS. Sorry, 3 availability zones in an AWS region, and then the fault tolerance will be availability zone level. One zone can be down, everything continues. But you can also choose multi-region, where you want either to partition by per region, and then it will create the table space that we need, or you can replicate across regions if you really want to. Now, for example, in Europe, we have regions with 10 milliseconds between them, and that can be okay. Also depends on the application. If the application is really doing things correctly, not row by row, if you have 1,000 rows to insert, if you send one insert with 1,000 rows, it's okay. You pay the latency only once. Of course, if you do it 1,000 times and commit 1,000 times, then you will pay the latency each time. So that also depends on the application design when you go multi-region. And basically, you want to be resilient, for example, to 3 regions, and then the replication factor will be higher. And there, when you are multi-region, then you are you need to map the region to the to VPC peering, for example, for the application to access to it. So you define all that, and then you have a cluster there, and that you can scale. So the commercial offer is support and database service. If you don't want to deploy on those three clouds and want to manage it yourself, you can also have support for it. And we have database as a service software that is not open source, that just helps to deploy in this case. So the database itself is open source. The managed service, whether it is a cloud portal or software that helps to provision thousands of databases, then this is part of the support, more as a service. It's more, yeah. On premises, you need a software to deploy correctly, similar to what we deploy in the cloud.
Yep, got it. Super clear. Thank you, Frank.
Yeah. I love the UI too. It's clean.
Yeah, it looks really nice.
Yeah. It's not easy to do something that is clean, not too much, but you also need necessary information when you need some logs. So yeah, it was not immediately from the first version very easy to use in all cases, but now we have also, for example, maybe it will take too much time to resume the cluster and show it, but for example, you have some performance view where you see the slow queries, where the basic things that we have. There is also a free tier in the cloud. So the free tier is quite small. It's 2 vCPUs, 10 gigabyte storage, but that can be sufficient. So without credit card, without anything, you can have a free tier.
Good.
Do not do your benchmark there because it's small, but if you just want to test the Postgres compatibility, before going further, you just want to be sure that your application that runs on Postgres runs there, and you are not hitting one of the few features that we don't support yet. Then just run it on the free tier, and that's easy.
Very cool. And obviously for our Cooper's users, you can just mosey on over to the GitOps catalog and click Yugabyte, boop, and then it's in your cluster. It's super easy, right?
Yeah. That's making it. That's the beauty of it. Having tools that make it easy, just one click for something that is quite complex. A database running on a multi-cloud, multi-region cluster is complex, but with automation in the database and with automation at all level, like with your services, then it make it easy. The only thing is that the user will think that a database is really easy because it's just a click, and don't realize that people are working hard behind it. But yeah.
That's right. That's right. With great simplicity comes great responsibility, right?
Yeah.
I love that. I love that. So, Frank, I assume you've shown like everything you wanted to show us today.
Yeah,
and more.
If there are more questions about it, and we can show something else. But yeah, that was the basic things that I wanted to show, the resilience and the elasticity. Those are the main reason. If you don't need this elasticity and if you don't need resilience, stay on Postgres. No need to go to something else if you are already on something where you don't need anything else. But if you are in Postgres and need more, or if you are in AWS or and need more resilience, that can be a solution. Or also, I see a lot of companies running on Oracle, and they want to move out of Oracle just because they want to go open source for the freedom it has. And I mean, Oracle has a lot of features, but not really freedom concerning sales and audits and all. So people want to move out from Oracle, want to move to Postgres because it is popular. But then they compare what they add on Oracle in terms of maximum availability with data guard, golden gate, and so physical logical replication, some kind of sharding also. And they compare that to Postgres itself, and there is no equivalent to RAC, the Oracle cluster. So that can be a solution, going to a database that is similar. Of course, you have something to change in the application to run from Oracle to Postgres. Depends what you use. If you use Hibernate, you change the dialect. But if you do a bit more, then you have to change something in the application. But at least you are going to Postgres where you have a lot of solutions. I mean, if you try Yugabyte and you think that you don't need it, you have plenty of different flavors of Postgres that are compatible. You can go to AWS or you can go to Google YugabyteDB. So you still have the freedom. You have one step to go from Oracle, the code for Oracle to Postgres, but then you have the freedom there, and you have the similar and even better availability in a distributed database when you compare that. So.
Really cool.
That sounds good. I need to say, Frank, you know, my time as a quote unquote DBA, I've never been officially like with the title, but like in my days, like 15 years ago and plus, when I was a full-time software engineer, software developer, I was working in small companies, so we didn't have DBA. So like developers were like architecturing and creating and managing the database, and I kind of miss writing queries and like building my architecture table. And like now you just like remind me like of the pleasure I had to play with like Postgre and databases. So thanks for sharing about Yugabyte. I think it looks like an amazing project, an amazing product.
Yeah, I couldn't agree more. I think back to those nightmares I used to have with these 30 terabyte Postgres databases with read replicas in different regions, and it was hard to move data. It was hard to replicate.
You can run very big databases on Postgres, but you need a big team for that. Yeah.
Yep. So really cool architecture. Love the open source. From my vantage point, you guys are doing everything right. So thanks for coming on the show and demoing it for our audience. I think there's a lot of users that should find a lot of good value out of it.
Yeah, and thanks to Piet for all the question. That was amazing, and you just commented, good story. Thanks. So thanks, Frank, for all the discussion, all the demos, answering all your questions. And Frank, as far as I know, you're going to speak at FOSDEM really soon. Do you want to share about that?
Yes, exactly. That's in 2 weeks, something like that, in Brussels for FOSDEM. So you have everything open source. So of course it's part of it. And I'm really happy because usually there are some dev rooms for Postgres, for MySQL. And this year we have a cloud native dev room. And I present about the Postgres compatibility, how Postgres was plugged on the storage. And I'm also happy because I'm doing a presentation with a competitor database with TIDB, but we present the building blocks, what we do the same and what we do differently. For example, WAFT is very similar. The management of the time between the servers are different. So really technical, even if in the market they are competing. It's really nice to discuss with developer advocates about the technology behind it, and so that will be really nice.
That's awesome.
That's great. I heard a lot of great things about FOSDEM. I think I attended it once, like many years ago, but I never spoke there. Now that there's like a cloud native track, John, I'm telling you live, I guess that's like next year we need to submit talks for FOSDEM. It's one of the main open source
I've heard
like
nothing
conference
but
out
great
there.
things about it. Yeah, I would love to get out there sometime. Make it happen, Fred. Make it happen.
Will do. And Frank, you may not know about that. We always end our live stream with a really bad developer dad joke. So, gentlemen, I have a question for you. What did the command line die of? So, what is the cause of death for the command line?
The command line died from a bad return code. I have no idea.
No, from a terminal illness.
Oh, that's fun. That's fun.
That's a good one, yeah.
Thank you. It's not from me. I find those on the internet, but it's the delivery. So on that note, people, thanks for joining us live. Thanks for the people who watched the recording. As always, we could not do that show without you, or we were just talking around ourselves, which is not the goal. It's for you folks. So thanks again, Frank, for joining us. That was a pleasure to have you on the show.
Thank you.
And again, thanks, John, also. Always having great questions and great comments for your guests. So I think this is the end. Is there anything else you want to share with the people, with the rest of the world, Frank, before we end the live stream?
Just follow, contact on Twitter, LinkedIn for whatever questions. The cool side of the job being developer advocate is really just helping users, but also getting feedback. If you have no questions, everything works. It's also good to know.
I totally agree. I mean, like, people tend to contact us when they have issues, they have problem, they have concern, but it's always nice also to just once in a while, like, you know what? I use your product. It's working well. I want that kind of feedback too. So do it
Yeah,
with
we're going
Frank.
to share that to the engineers. Yeah.
Yeah. So do it for Frank, but think about this guy too. If you use KubeFirst or Colony, let us know how it goes. So on that note, thanks again, everyone, and we wish you a great rest of the day, and see you in 2 weeks for the next KubeFirst Live.
Thank
See
you.
guys.
Bye.